All right, so I'm going to take you through Math 225 homework number 6. This is dealing with the distribution x bar. So the first problem that we had to do was we had to figure out what the mean and standard deviation was for the population given these values as our population. So the population standard deviation and the population mean are what we're looking for. And these are all 5 residents, so the population is all 5 of them. So this is not data. We're going to be pulling data from that in the future. So what we're going to do is we're going to go to our calculator, go to our lists, clear out a list, and enter these numbers. So 12, 13, 17, 20, and 21 should be all that's there. So we're now going to run our 1var stats to find the mean and standard deviation of this population. So stat and calculate 1var stats. We're going to just tell it L1. We'll deal with the L1, L2 in a little bit, but this is just a set of data. This is Unit 1 stuff here. All right, so x bar is 16.6. That's actually mu. So this means, no, excuse me. Mu is equal to 16.6. And the standard deviation we want is sigma because it's a population, so it's at 3.361. Sorry, 3.611. Note we're not taking S. S is for a sample. This is clearly a population here. All right. Now, the next thing we want to do here is calculate x bar for each of our samples. So we have a sample of n equals 2. So we're going to find these are each different possible combination of the 2 values of 5. So it's basically 2 choose 5. So we're looking at 5 choose 2, excuse me. And that's the same thing as saying 5 combination 2, and there'll be 10. We can do that in the calculator here. So 5 math probability NCR 2 gives us 10. And I've listed all the 10 different possibilities that we can do. Each of these individual pairs is equally likely. And that's what's going to help us with the probability part in once we're done. So all we're doing here, so our very first one, this is 12 plus 13 over 2, which is 12.5. So all we're doing is finding the mean of each of these different numbers. These two add up to 29, so this is going to be 14.5. These two add up to 32, so this is going to be 16, and so forth. Just write what I have down here now. Should be a decimal there. All right, so now we're going to try to write these in ascending order here. The lowest one is at 12.5, so 12.5. Then the next one is a 14.5. And we've got a 15 right there. We've got a 16 up here. And then we've got two 16.5s. And that's just this order here, 17, 18.5, 19, and 20.5. So the probability, since there's 10 different possibilities and each one of them is equally likely, all of them, each of these individual combinations has a probability of 0.1, 1 in 10. Now there's 2 ways to get 16.5. So that one's actually a probability of 0.2. All of the rest of them will be just 0.1. 1 out of 10 is fine as well. Now, I'm going to show you on this one, but I'll probably forego after that and just write the answers. We're going to put these values in our chart here into our calculator. So let's clear out these two lists. And enter the values. So we have 12.5, 14.5, and so forth. So those should be our 10 values. Then we're going to go over to list 2, and we're going to put in the probabilities. And all of them are 0.1 except for the 16.5. So, and I don't know what I did here. Let's just clear this out. This one's 0.2. The rest of them is 0.1. All right. So now that we have this, we're going to run the 1var stats. And we're going to put in L1, comma L2 to let it know that we have two parts we're looking at. We're looking at the probabilities as list 2, or this could be frequency if you've got a frequency one. If you're using the display wizard, the first list, the X list is L1, and the frequency list will be L2. So stat, calc, 1var stat, L1 second, 1, and then the commas above the 7, and second 2. So this tells us that x bar, which is our mu, is going to be this 16.6. That's where we write it down there. And we don't have an S because it's not a sample. So this 2.211, what do we want? 3 decimal places, 2.211 is our standard deviation. Now, we can also calculate these things using our formulas. Now, note, let's do this. That the mean of x bar is equal to mu, which should equal our 16.6. And our standard deviation of x bar will equal sigma over root n, which will be, our sigma is 3.611 over root 2. And that comes out to about 2.553. Now, ideally, you want this stuff over here. This is what we're actually trying to do to show what's happening. However, if you answered this way instead, it was fine. That's certainly a way to determine what it is. And notice those two numbers are not the same. This is our approximation of what it should be, whereas this is our actual value here of what the standard deviation of each one involved. All right, so the same process works for this next one. I'm just going to write in the answers here. I took these as, since there are 3 of them, I added them up and divided by 3. So let's go back to purple here, whatever this is. So this is 42 over 3. That would be x bar. We add these 3 up. They add up to 42. We divide by 3. If you want to do the actual bit and do it to the decimal, that's fine. I just chose to leave it as fractions. Now, that being said, let's go back to our calculator here. Let's clear out these lists again. So our first one, we're going to type in 42, and we're going to go divide by 3. And this one turns into a fine number. There's no issue with that. But let's go over a couple of these and see what happens. So this one adds up to 45. Well, 45 over 3, the 45 is also divisible by 3, but 45 divided by 3. There we go. This next one causes a problem, though. This is 46 over 3, and those two things are not divisible. So we're going to get this repeating value. But I entered the whole thing in the calculator as 46 divided by 3, since that's kind of how it would work instead of rounding. This is going to get me to the actual answer, and we'll get you the actual X bar answer or mu of X bar answer in the future. But anyway, so this next one is these add up to 49. These add up to 50, 53. These are 50 again, 51, 54, and 58. And again, if you want to just do the division and put down the value 14, 15, 15.33, something like that, that'll work too. All right, so again, there's only one duplicate. This one and this one are the same, so we're going to basically write these in order. 42 over 3, 45 over 3, and so forth. And we have the 50 over 3. There's two of those, so that's 0.2 again. The rest of these will be 0.1. And now we've got a 51, it looks like. 53, 54, and 58. All right, and all of these will have probability of 0.1. All right, so when you enter these in the calculator, as I'm doing here, I guess I'll do this one too, that's fine. All right, so we have 49 divided by 3. Oop. I want to be in the calculator here. See if this works. 49 divided by 3, that works. We did the 46. All right, so 50, 51, 53, 54, and finally 58. And again, we'll move over to, there's 10 of them. No, hold on. What did I mess up here? Oh, there's 9. There's 9 spots. There's 10 original probabilities, but one of them is a duplicate. That was the issue. Fourth one is 0.2. The rest of them are all 0.1. All right, and we do the same thing, stat, calc, 1 var stat, and we tell it L1, comma, L2. So again, we have the 16.6. This standard deviation is 1.474. And again, if you want to do the sigma of x bar, that would be sigma over root 3, which would be 3.611 over root 3, which comes out to about 2.085. So again, this is the answer I was looking for. However, I will take this as well. Okay. The next one, we add these up and divide by 4. I'll list the values here. These this gives us 15.5, 15.75, 16.5, 17.5, and then 17.75. And these numbers go here because they're in the same order, and there's only one of each. And all of these probabilities are 0.2. Since there's only 5, 1 out of 5 is 0.2. 1 divided by 5. When we run these in the calculator, we get the same 16.6 as we always should. And our standard deviation becomes 0.9028. And remember, sigma of x bar gave us sigma over root 4, which is 3.611 over 2, which is about 1.8055, something like that, or rounding to 3, change that to a 6. If you give more, I'm fine with that. Just try to give me at least 3 since I asked for 3. All right, and finally, the questions that relate to all of these informations, we're just looking at these different distributions of n equals 2, n equals 3, and n equals 4, and trying to figure out what we have here. We're looking for the smallest and largest sample and what their distance away from the mean is, right? So the smallest for n equals 2 was 12.5. The largest was 20.5. So smallest is going to be 12.5 minus 16.6. That equals negative 4.1, not positive 4.1. Largest gives us 20.5 minus 16.6, which is 3.9. So the difference between these two values is a sampling error, excuse me, and it appears to be 8. If we take 3.9 and subtract negative 4.1, so 3.9 minus negative 4.1 equals 8. That's our sampling error for our first one. Do the same for n equals 3 and n equals 4. So let's do n equals 3. Our smallest there was 42. So smallest. So 42 over 3 because it would have been a mean. That's what we got. We're subtracting that 16.6, and that comes out to about negative 2.6. And the largest was, I think it was 58. 58 over 3, yeah. And then it comes out to 2.73. And then for n equals 4, small and large, the small value was 15.5. And the difference between that and the mean were negative 1.1. That's closer to 0. And then above, 17.75 minus 16.6 is 1.15. And what do we notice? Well, we notice as we increase n, the margin of error gets smaller. These two numbers are closer together, and these two numbers are closer still. So margin of error gets smaller. Something along those lines. For each sample size, how does the mean well, that should say x bar. So the mean of, here, let me write it in black. Mean of x bar compare with the population mean. Well, they're the same. Now, some of you did the middle one with, instead of dividing, 45 divided by 3 or whatever, you just gave me the decimal. So it came out to a number very close to 16.6. I think it was like 16.59 or something like that, or 592. And you wrote that they're all close or equal. That was fine. Again, you should always get the same value, but if you're going to do rounding, then you can have some issues. Now, what happens with the standard deviations? Well, if you notice, as n got larger, n gets larger, the standard deviation gets smaller. So we're looking at these values here. So take our first value, 2.21 to 1.474 to 0.9028. As n got bigger, our standard deviation of x bar got smaller. And that's how you solve this homework. Not too terrible. You can certainly email me with questions as well.